Hello and welcome to the next section in our Rust Data Structures and Algorithms course. During this video, we are going to be talking about linked lists. Now, a linked list is fundamentally a list of elements, each pointing to the next, which makes it very easy to insert a new element if you're at the right place by simply changing the pointer on the current element and setting the pointer on this element to pointer to the next element. They are generally most useful for some kind of stack object, as they're very easy to insert at the front and very slow to insert at the back, as you will see. So let's start this by creating a pub struct linked list, and this will take a type T, which will be whatever it's going to store. It's worth noting as well that linked list can of course be empty. Therefore, we're going to take an option of its data type, that's T, and the box of another linked list. As I mentioned before, we kind of need to wrap it in a box, otherwise we get an infinitely sized list. So the box is just a pointer to another one. And then we wrap those in a tuple and wrap that in an option. So we may or may not have an element. Let's derive debug for this so we can show how it works as we build our list. And then let's just create an import for a linked list of type T. And again, we'll need to declare that T at the beginning of the import. So we have a public function, a new, and this will return a self, and this will just return a linked list of none. So there's nothing in this linked list. This is the empty list. After that, let's start writing our push front method. So our push front method will take this current list in a mutable way and also the data that we want to add to the front, and it will just change the list so that this new element is at the front. So we're going to do let T equals self.0.take. 0 is the first element of self being the linked list. So the 0 is the option, and take removes the first value from that list and gives it to our variable. But T remains an option. Once we have this, we can set self.naught to a new value, and this will be an option, a sum of this tuple with data, and then a new linked list pointing to what was previously the front of this list. So in that case, we're going to have to wrap something in a box, and we're going to create another linked list, and we're going to use T as the data object. T is an option of data and linked list. It may or may not have them, but that is what the contents of a linked list should be. Now, as I'm writing a lot of these data structures in Rust, you'll find that some of this is quite awkward to write. And as you're writing it, you're going to get a lot of errors come up. But the nice thing about this is when you finally get it to compile, it's probably correct. It can be quite awkward to think your way around the linked list and the box and everything like that. But the compiler will point you in the right direction if there is a problem. Now let's try and write a method to push at the back of the list. This is trickier because we only have the front of the list, so we have to find our way to the back, which means we have to recurse there. So let's match on self. If we have an element with a future element, that's where we want to add to that. So in the case of sum, we don't care what the data is in sum, but we do care what the child is, and we'll take it as a reference, a mutable reference, and then we'll do child.pushback data. In the other case, self.0 is none, in which case we just want to set self.0 to the new value. And the easiest way to do that is to call self.pushFront. So in our main function, let's just create a new linked list and add some elements to it. ll.pushFront 3, ll.pushback, so we want it to go behind the 3, let's make it 12, and ll.pushFront will push a 1. So we know that these should come in order, right? The 1 should be in front of the 3, in front of the 12. So when we call println on ll, and we'll use its debug form, we should have a list that starts 1, then 3, then 12. So get to the right folder and type cargo run. And here you see we have a linked list. The first element is 1, the second is 3, and the third is 12. And the way this prints, it's like each one contains the next. Technically, they are just pointing to the next, but with the way a linked list works and the way Rust makes this work is that it's easiest to think of them as containing the next, which is why there are so many brackets at the end. Hopefully that will make sense to you, and if it does, you'll be able to do this challenge without too much difficulty. See if you can add a new element in a sorted way. So instead of us choosing push front or push back, I want you to just be able to write insert sorted, and assuming the rest of the slice is sorted, you should be able to add your new element in the correct place. So you're going to find the place where it needs to go, and once you've found that place, you can just call push front. In order for this to work, the T of your impl will need to be partial ORed. So impl angle brace T colon partial ORed close brace, and then begin your impl on the struct. But apart from that, everything else should be pretty straightforward.